Hey all, today we're going to talk about constructing confidence intervals a little bit more, and this time we're going to talk about constructing confidence intervals that pertain to comparing two proportions. So we've made confidence intervals with one proportion, and so now we want to compare two different proportions. So it's going to be fairly similar, except we're going to have to show a difference in proportions. So our original confidence interval had a p hat on the left here, and now we have p hat 1 minus p hat 2, showing a comparison by finding the difference between the two proportions. We're still going to have a margin of error that we add and subtract to our difference in p hats, and that's still z star by some standard error. And our standard error is going to be a little bit different because it's a standard error for the difference of the two proportions. We'll still find our z star the same way based on our level of confidence, and we can make that calculation using our calculator. It's a little bit more complicated down here to find the standard error. We originally would do p hat times q hat divided by n, the sample size. So now we have to do that for both proportions, so both p hats, and then we add them together and take the square root. So we're kind of just doing this twice and adding them together before we take the square root. The process other than that is the same. So let's do an example. This is from the book if you want to read it there. If not, you can read it right here. Take a second, pause, and read this example. So here we're surveying some teenagers. The ones that they ended up being interested in are specifically age 15 through 17, and we're wondering about the percentage of them who post online profiles. So that would be to you like Instagram accounts or Snapchat. Most of y'all don't use Facebook anymore, but that type of idea. And then so we have separated them into boys and girls because we want to compare the difference between boys online profile posting and girls online profile posting to see if one posts more than the other. And so in our sample, 57% of the boys post and 70% of the girls. So we're going to create a confidence interval to try and find the true proportion that represents the difference in girls and boys in their online posting. So we've got to check assumptions and conditions like we always do. We need our sample to be randomly selected. It was. Here's a subtle difference. We need both groups to represent less than 10% of the population. So we need the boys to be less than 10% of all teenage boys and the girls to be less than 10% of all teenage girls, which it is. Then we need to check NP and NQ for both groups. So I find the number of successes, the number of online profile posters for boys is 141, and 107 of them don't post. I have to do the same thing for girls. I get 179 and 77 who don't post. So we're checking NP and NQ being bigger than or equal to 10 for both groups. Okay, so same assumptions and conditions. We just have to make sure they exist for both groups we're talking about. And so now we can start building out our confidence interval. We're going to have to subtract p hat. We're going to do girls minus boys. The girls had a larger p hat, so we'll do girls minus boys and get a positive number here. Z star for 95% confidence is 1.96. And then we got to make this calculation for the standard error for girls and boys. And sorry, that should have an SE in there. So we're doing our p hat for the p hat q hat for the boys divided by the sample size of boys. P hat q hat for girls divided by the sample size of girls. We make those two calculations, add them together, and take the square root. We get 0.0425. And so now we can build our interval. Our margin of error here is 0.083. We add and subtract that to 0.13 to get our final interval of approximately 4.7% and 21.3%. So this represents how the percentage more that girls post than boys. So what we have is the true proportion of girls who post more than boys is somewhere between 4.7% more and 21.3% more. So we should interpret our interval. Whenever we create an interval, we want to interpret it. What does it mean? What do these numbers mean? And we are 95% confident that among teenagers aged 15 through 17, the proportion of girls who post online profiles is between 4.7 and 21.3% more than the boys who post online profiles. Now we could have done this with boys first, and we would have gotten some negative numbers, and we would just interpreted that if our interval became negative, that the boys are posting less than the girls. Okay, same idea, just sort of phrased differently. It's kind of maybe it makes more sense, and it's a little bit neater to have these positive numbers and say that the girls are posting more rather than the boys posting less. So we'll do some of these in class. You might guess that it'll follow that we will, in the next lesson, talk about hypothesis testing for difference in proportions. For now, we'll focus on creating some confidence intervals using two proportions. If you have questions, make sure you're ready to answer them in class or ask them in class.